Hi students, this is plus 2 mathematics, chapter number 6, application of vector algebra. The important topic is types of planes. There are a lot of planes, equations are there. Now we are going to study about just 3 types here. The first one is equation of plane, then a normal to the plane and the distance of the plane from the origin are given. Look the diagram here. This is coordinate axis, x-axis, y-axis, z-axis. Consider the plane. This is a plane, okay? Now, the plane has a normal vector, okay? This is nothing but d cap. D cap is unit normal vector, okay? Right. And this here, small d. The small d is nothing but, small p is nothing but the distance between the plane and the origin. A plane and the origin. So then the required equation of the format is r vector dot d cap is equal to small p. Here r is nothing but OP. OP vector which is equal to r vector. And here OA which is equal to small p. Right? So r vector dot d cap is equal to p. Here the d cap we can convert into d vector. So r vector dot d vector which is equal to q, where d cap is written as d vector divided by magnitude of d vector. Okay, so this d goes to that side. This modulus of d, for example, I wrote here in the explanation here, r vector dot d vector divided by magnitude of d vector which is equal to p. Then r vector dot d vector which is equal to p into magnitude of d vector. So now the p into magnitude of d vector is gives a value such that is a q, because this is a scalar, p also scalar. So product of two scalars, it will be another scalar. So r vector dot d vector is equal to q vector. So this is the formula for finding the equation of plane when the distance is given. Okay, the distance between origin to the plane, okay, and a normal vector will be given. Right. Next, equation of plane perpendicular to a vector and passing through a given point. So now we are finding the equations of plane when one point is given and one normal vector is given. So look this diagram. So this is the coordinate axis and A, B given points. Okay, so A is the point. So this OA is equal to A vector and OP, this is P. So OP vector is equal to R vector. And consider the plane. This is nothing but normal vector M vector. Okay, normal means perpendicular, right? Perpendicular to the plane. Perpendicular vector to the plane. So one normal vector. One normal vector, one point is given, means then the equation of plane in vector condition r vector minus a vector dot n vector which is equal to 0. We can write like this also. R vector dot n vector which is equal to a vector dot n vector. So this is the Cartesian form. A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. In general form, the equation of plane is nothing but ax plus by plus cz plus d equal to 0. Here x, y, z, then constant. If removing z here, we get the line equation. This is nothing but line equation. Ax plus by plus c is equal to 0. In 10th standard, we have studied about the line equation. Okay, because here only two axes involved, x and y. If you are involving z axis here, the line equation will come as plane equation, because three coordinate axes, x-axis, y-axis and z-axis. Now, type 3. So, equation of planes in intercept form. What is intercept form? We want to draw x-axis, y-axis and z-axis. We do video algebra. And intercept form means you want to take any point on x-axis, any point on y-axis and any point on z-axis and match, join it. Any point on the x-axis is nothing but a, 0, 0. Any point on the y-axis can be written as 0 comma b comma 0. Any point on z axis we can write 0 comma 0 comma c, where a is the distance between here a, b, c. Small a is distance between that means x intercept, and b means y intercept, the c means z intercept. Okay? Then we have the parametric equation r vector is equal to 1 minus x minus t into a vector plus x into b vector plus t into c vector. So we can write like this also. So a vector plus s into b vector minus a vector plus t into c vector minus a vector. This is the original form. Okay, so this is the original form. We are simplifying, we get it is easiest method. Okay, there is two types, nothing but a parametric equation of plane in intercept form. Now non-parametric. What is the difference between parametric and non-parametric? In straight line, the last video I will teach about the difference between parametric and non-parametric. Parametric means the scalar will be present. Okay, here non-parametric, the omitting of scalar, we get the format is nothing but a non-parametric vector equation. It's very simple. Just bring right side a to left side, r minus a, and the entire. Whenever they are adding scalar, put that. Then these two terms we want to multiply with the cross product equal to 0. Now Cartesian form. 1 dot 1 cross. 1 dot 1 cross means box product of. Okay, so we can write like this also. R vector minus a vector, b vector minus a vector, c vector minus a vector, which is equal to 0. So this is another form of non-parametric form of plane. So now Cartesian equation, this is a box product. You know very well, box product means you want to put determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. So this is the three types now. We will see the based questions on next video. Okay. Hi students, this is example 38. Find the vector and the Cartesian form of the equation of a plane which is at a distance of 12 units from the origin and perpendicular to the vector. We are given the distance between origin to the plane and a perpendicular vector. Okay. Now we know very well the form. The equation is nothing but r vector dot d cap is equal to p. Now, I want to write given that p, small p, this is nothing but the distance between origin to the plane. This is 12 units. And d vector is equal to 6a vector plus 2j vector minus 3k vector. We need d cap. D cap is nothing but d vector divided by magnitude of d vector. So, 6a vector plus 2j vector minus 3k vector divided by magnitude of d vector is nothing but square root of 6 square plus 2 square plus of minus 3 the whole square, which is nothing but 6a vector plus 2j vector minus 3k vector divided by square root of here 36 plus 4 40 plus 9 41. So which is nothing but d cap is equal to 6a vector plus 2j vector minus 3k vector divided by 49 is nothing but 7. Now we know d vector, right? Now let's see the equation of plane, right? The equation of plane, is r vector dot q cap, which is equal to small p. So r vector dot here d is nothing but 6a vector plus 2j vector minus 3k vector divided by 7, which is equal to 12. So take it to 7 that side. So we have r vector dot 6a vector plus 2j vector minus 3k vector, which is equal to 12 7s are 8. This is vector equation. Now we want to find Cartesian equation. Okay, I write short form Cartesian equation. Here r vector is nothing but xi vector plus yj vector plus zk vector. Therefore substitute here xi plus yj plus zk dot 6i plus 2j minus 3k, which is equal to what? 84. So now product I to I, j to j and k to k. So 6x plus 2i minus 3z, which is equal to 84. So this is required Cartesian equation of the plane. Hi students, this is example 39. If the Cartesian equation of the plane 3x minus 4y plus 3z is equal to minus 8. Find the vector equation of plane in standard form. Find the vector equation of the plane in standard form. So, we have finished the first one, first this is the second sum. The standard form of vector equation is r vector dot d cap, which is equal to p. This is the vector equation of the plane. Okay. So now given equation is solution. Given Cartesian equation is 3x minus 4y plus 3z, which is equal to minus 8. So this one we can write like this: xi vector plus yj vector plus zk vector dot 3a vector minus 4j vector plus 3k vector, which is equal to minus 8. So now this vector equation we want to bring into the form of r vector dot d cap, which is equal to p. Before that, the right side p, this is distance between a plane and the origin. So the distance means it should be a positive, but here minus 8, it is a negative, so you want to multiply with the negative sign. So this is a product, okay, so we don't multiply minus with this term, so we can multiply to this term, right? So xi vector, that is minus 1 into multiply minus 1 on both sides. So xi vector plus yj vector plus zk vector dot. This minus I taken into this bracket only. So minus 3a vector plus 4j vector minus 3k vector, which is equal to plus 8. Now the right side will be plus. Okay. Now d cap, we want to make a d cap. So d cap we can write d vector divided by magnitude of d vector. Alright. So here this is side what? D vector, which is equal to, what's the d vector here? Minus 3 plus 4 minus 3. Minus 3 vector plus 4j vector minus 3k vector. What about magnitude of d vector? So magnitude of d vector, we have to take in squares of the values. Square values of ijk component. That is minus 3 the whole square plus 4 square minus 3 the whole square, which is equal to 9 plus 16 plus 1, 9. So adding this one, we get 25 plus 34. So root 34. Now we have to divide by root 34 on both sides. So xi vector plus yj vector plus zk vector, simply we can write r vector dot minus 3a plus 4j minus 3k vector divided by root 34, which is equal to 8 divided by root 34. So this is the required vector equation of the plane. Okay. Hi students, this is the example 40. Find the DC. This means the direction cosines of the normal to the plane and the length of the perpendicular from the origin. So they are given, normal vector is given, and distance between origin to the plane also given. So r vector is equal to r vector dot 3 vector minus 4j vector plus 2k vector equal to 5. Then we want to find out the direction cosines. So in this question, we want to convert this vector equation into the standard form of r vector dot d cap, which is equal to what? P, small p. Here, this is a form r vector dot d vector, which is equal to q. This is the form of r vector. You see the relation between these two. Don't confuse here. this is D cap. D cap, when you are writing D cap, you mention it is P. And D vector is nothing but P into magnitude of D vector. So R vector dot D vector is some value, this is something but Q. Right? Now we want to bring this equation into this format. R vector dot D cap which is equal to P. But here the relation is R vector dot D vector which is equal to Q. Okay? Right. So solution. Given equation is vector equation is R vector dot 3 vector minus 4j vector plus 12k vector which is equal to 5. So here B vector which is equal to 3 vector minus 4j vector plus 12k vector and then Q is equal to 5. And we want to take magnitude of D vector. Magnitude of D vector, so taking the square root of 3 square plus of minus 4 whole square plus 12 square. So 9 plus 16 plus 144 which is equal to 169. Taking square root of 169 which is equal to 30. So name it as the equation number 1. Now first equation divide by 13 on both sides, right? So divide by 13. First equation divided by 13 on both sides. What do you get? R vector dot 3 vector minus 4j vector plus 12k vector which is equal to 5. So you want to divide by 13, no? So write 13 here. So therefore, the D cap which is equal to 3 vector minus 4j vector plus 12k vector divided by 13. And small p, the perpendicular distance between origin and to the plane is 5 divided by 13. So this is the standard form of R vector dot D cap which is equal to P. Now they are asking DC. DC means direction cosines. Therefore, direction cosines of normal vector. So this is this one. Direction cosines. Take out the components of IGP. So 3 divided by 13 and minus 4 divided by 13, then 12 divided by 13. So this is the required direction cosines of the problem. Okay.